Hello, this is Hui. Welcome to watch my video C++ programming on Linux. In our last video, we have explored the crucial concept of no blocking I/O with TLS SSL. In this short video, it will apply that powerful paradigm to another essential secure protocol, SSH, the Secure Shell Protocol. The library we are going to use in this video is Libssh. The Secure Shell Protocol SSH protocol is a cryptographic network protocol for operating network service securely over an unsecured network. While TLS protocol focuses on secure data in transit, SSH provides a secure channel over an unsecured network to run network service securely. The most popular usage of SSH is for login to a shell on remote host, for executing command on remote host, for development on a mobile or embedded device that support SSH, for securing file transfer protocol SFTP, secure copy protocol SCP, for securely mounting a directory on a remote server as a file system on local computer using SSH-FS. One of the most used SSH library is Libssh, and here is the useful Libssh reference website for developing with Libssh library. As we know, blocking model I/O can halt the application flow, especially in an interactive or high-performance scenario. Instead, no blocking model handling I/O operations asynchronously while waiting for a read or write operation to complete. The application can perform other tasks and check back later. Here on Linux, the environment we are using of this video is Ubuntu Linux Release 2404. Libssh is included in this release, and if not, you can install using command. Since we have already installed, so there's no newly installed in our environment. In previous video, we have written a C++ example, SSH cmd.cpp, to execute a command on a remote host using Libssh. This is a block model example. First, we compile and test our previous examples. Now, program has been compiled. This is our executable SSH cmd, and we are on the host IP address 10.0.0.191, and we are going to run this command to connect to another Linux 10.0.0.124, which is our Debian Linux. Usage, first argument is a server 10.0.0.124, port number is 22, default for SSH login ID, and we're going to run 3 commands. First command, host name. Second command, pwd. Third command, env, the password. So you can see after we log in to the remote host 10.0.024, port number 22, and the first command is the host name, is Debian, which is our Debian Linux. Success. Second command is pwd, value is home, HYUAN, and the third command is env, which is the environment of a remote server. And our SS connection from 10.0.0.191 connect to the 10.0.0.124 part number 22, and we successfully run command on the remote server. Now we update our previous example from block model to no block model. First, the parameter structure has no change. To running a command on remote server or remote host, we have to have a server, port number, login ID, the password, and the command vector. It's the old command we are going to run on the remote servers. The usage will not change. First argument is server of remote host. Second is the port number. By default, SSH port number is 22, login ID for login to the remote host, and then we can put one or multi command to run on the remote servers. First, we declare the parameter mparam, take the server from argument 1, the port number from argument 2, login ID from argument 3. And then we make a loop from argument 4 till the end, push the command into command vector. We get a password from the terminal using silence model, and then we call the function SSH session functions. To running command on remote host, first we have to start a SSH session. In older version of lab SSH, the first function will be the SSH underscore init, and the last function will be the SSH underscore finalize. In the new version, this function is not necessary anymore. Function SSH underscore new will start a new session. We name session. If a session is none, it means start a new session error. We just exit with error -1. After session has been created, most important is to set session option. The function is SSH option set. The SSH option set function sets the option of the session. The most important options are SSH option host, which is the remote server. SSH option port is the port number of a remote host. SSH option user is the system user under which you want to connect it. SSH option log verbosity is the quantity of message that printed. Back to our editor. First, we set up SSH option host, which is our server, from command line. SSH option log verbosity, we are going to set SSH log, no log for this demo, and SSH option port, which is port number from command line argument, and SSH option user from command line, which is login ID of remote server. For the block model example, after we set up a session option, we can use SSH connect the session to the remote server. To convert to the no block model, before we connect, we need to set up session as no block. Lab SSH has a function called SSH is blocking. This function returns 0. Session is no blocking. If 1, the session is block models. To set up a session with a block or no block model, using function SSH set blocking. This function set the session in blocking or no blocking model. This function has two parameters. First parameter is the session, and the second parameter is 0 for no blocking model, 1 for blocking model. If session is a block model, return code is 1, then we call function SSH set blocking, which parameter 0 to the no blocking model. Next step will be perform session connect to remote using function SSH connect. In blocking model, this function return back after connection completed. In no blocking model, this function may return back even the task has not completed, so we need to create a waiting socket ready functions. In previous video SSL no blocking model example, we have created such function. In order to save in type, we just copy and paste here. This function using select system call to monitor the socket until the socket is ready. Back to step 3, session connect to remote using function SSH connect. Function SSH connect to the SSH server. This function returns SSH OK or SSH error on error and SSH again if the session is no blocking model and the call must be retry again. Back to our editor, we made adjustment here. We create a do while loop. While return code is SSH again, keep looping and try. Call SSH connect. If return code is SSH OK, it means connect success. If return code is SSH again, print a message, retrying, and call the function, the socket using function, continue. If return code is SSH error, exit from loop, print a message, error SSH connection. Now finished update SSH connect from block model to no blocking model. Next step, convert function SSH user out password from blocking model to no blocking model. Function SSH user out password will authenticate by password. This function has a return code SSH out error, denied, partial, success, and again. For this demo, we only handle success and again. All the rest we consider as errors. So we only handle success, again, and the rest of the returns are all considered as errors. If success, exit from loop. If again, print the message, retrying SSH user out password, get error code and error descriptions. Then continue retry. After exit from the loop, if return code is error, we just print a message, disconnect and freeze the session, exit with errors. Next, use a for loop to execute command on the remote host. For the INTI from 0 to command vector size, first print the information what command we're going to run on the remote host. First function is allocate a new channel of session for running the command. This function don't have blocking or no blocking model. Next, convert the channel open session from the blocking model to no blocking model. Function SSH channel open a session channel for the shell, not TCP forwarding. This function returns SSH OK on success, SSH error if error, and SSH again in no blocking model, retry again. If return code is SSH OK, print the command SSH channel open session success and exit from the loop. If return code is SSH again, we print a message, retrying, print the info message, wait socket ready, and continue. After loop, if return code is error, we just print the message and we continue for the next command. Next, convert SSH channel request execute for sending remote command request from blocking to no blocking. Function SSH channel request exit function has a return code SSH OK on success, SSH error if error, SSH again if in no blocking model, and retry again. Do the channel request execute command on the remote. Else is SSH error. If return code is SSH OK, exit from loop. If return code is SSH again, we print info message. Retrying this option again with the error code and the error message. And continue retry. After exit from this loop, if return code is error, we just print an error message and continue for the next command. After send remote command request, it's going to read remote server response date. Function SSH channel read channel in block model. For read channel in no block model, function is called SSH channel read no blocking. Function SSH channel read no blocking do a no blocking read. This function return number of byte read SSH again if nothing is available, SSH error on the error, and SSH EOF if channel is EOF. Back to our editor. We declare a variable timeout, and the SSH read no blocking function will return immediately even channel is not ready for read. Between each read timeout for sleeping 100 milliseconds. So the condition it will be if channel is not EOF and the timeout greater than 0, keep the loop. After read no blocking, check the return code. If SS error, exit from the loop. If any byte greater than 0, it means we read some date. So we print out read buffer and reset timeout. If any byte is EOF, channel completed. Exit from loop. If any byte is SSH again, it means channel needed to retry. We copy 1, 2, 3 line, 3 YY. Retrying, channel read. No blocking error, and wait socket is ready, and continue retry. After exit from loop, if any byte less than 0 means error, we just print out the error message. Finish reading channel response. Next step is going to send UOF to remote. This function no need to convert, and after going to waiting, the channel is UOF. Do while loop. We cut this 2 line to DD. Each loop we memory set and read channel. No blocking. Check return code if so if RC greater than 0, it means the channel is not a EOF yet. Continue. If RC is a EOF, we exit from loop. If RC is SSH again, it means we need a retry. Wait socket ready and continue retry. If error 3YY, copy 3 line, paste here, print the error message. Then we delete 1, 2, 3, 4, 5, 6, 7, 8. Delete this 8 line. Next is a close channel and free the channel. These two functions don't need to convert. Finish, execute all the command. We disconnect and free the session and return code. Finish, convert our program from blocking model to no blocking model. We save our program, WQ. We compile our program. Now our program has been compiled. This is our executable. After converted, SSH CMD is no blocking model. To test our example, we are going to run our executable SSH CMD on Ubuntu Linux. IP address 10.0.0.191 and send the command hostname pwd and env to execute on remote Debian Linux. IP address 10.0.0.124. Usage first argument is remote host 10.0.0.124, power number 22, login ID, and we are going to send the command hostname pwd and env to execute on our remote host. First, input a password. After typing in the password, start our program. So you can see before complete SSH connection, program has 4 times retrying, 2 times retrying for operation. SSH use outer password and 2 times retry for SSH channel open session. This is our first command, hostname. This is respond back vh Debian. This is our second command, pwd. This is return of command, pwd. This is our third command, env. And here is the response of command env SSH connection from the 10.0.0.191 connect to the remote 10.0.0.124 port number 22. As we can see, no blocking model I/O handle I/O operation asynchronously. While waiting for operation to complete, application can perform other tasks and check back the SSH operation later. This may cause your program a little complex, but improve program efficiency, especially in interactive or high-performance applications. Hello, thanks for watching my video. Wish it is helpful, and it's going to be great to have your feedback.